Go ahead and do a little bit more AP review. This is 2012 AB number 4. It was AB only. We are given the function f of x equals the square root of the quantity 25 minus x squared from -5 to 5. It's not a bad visual if you can pick up that this is a semicircle of radius 5 centered at the origin. You don't have to know that, but it's not terrible for you to know. Yeah, anyway. Cool. So let's proceed with part A. So part A asks us to find f prime of x, right? So f of x is actually this whole thing, 25 minus x squared all to the 1/2, right? So my f prime of x is going to be 1/2 times this 25 minus x squared quantity to the -1/2 times the derivative of the inside, which is going to be a -2x. So I'm going to end up getting that this is a negative x, right, on top of a square root of 25 minus x squared, or any version of that is just fine, but that's my f prime of x, right? So a negative x on top of the square root of 25 minus x squared. So that's my f prime. And that's all part A asked for. It is in the same, it is in the domain restriction that was given, except you can't actually have values that are at the two ends at -5 and 5 because they would make the denominator 0. But cool. So second bit, part B, is write an equation for the tangent line at x equals -3. So we've done a bunch of tangent line problems, right? Anytime you're asked for the equation of a line, you need two things. You need a point, right, which is going to be -3 comma whatever the value of the function is at -3, which we're going to find in a sec. And you're going to need a slope, which, because this is calculus and we want a tangent line, my slope is going to be f prime of -3, right? I already have f prime from part A, so that was convenient. So I'm going to use my part A to find the slope, and I can go ahead and use the original function to find the y value. So my point, if I plug in f of -3, it would be the square root of 25 minus a 9, which is root 16 or a 4, right? And if I plug in my slope, right, f prime of -3, my tangent slope, should be a negative of a -3 on top of a thing that we have already established as a 4, right? Because we already plugged in up here and got that that's 4. So I get 3/4. So my slope is a 3/4, and my y value is a 4. So I get that my answer for the equation of the tangent line is y minus the y value, so y minus 4, equals m, which is the quantity 3/4, times the quantity x minus the x value, so I'm going to write that as an x plus 3. Now, they did not ask you to solve for y, so this is an absolutely acceptable answer. Had they asked you to solve for y, the easy way to solve for y is to just add the 4 to the other side, and then leave everything else exactly as it is, right? And that's also an acceptable answer. Cool, and that is all they want for part B. All right, so part C. Part C says, let g be the function. So now we have this g of x in part C. Right, g of x is a piecewise function that is f of x on the window we were given, right, from, part of the window we're given, from -5 until -3, but then it behaves as an x plus 7, starting at -3 and going until 5, right? So is g continuous at x equals -3? Use the definition of continuity to explain your answer. So what it means to be continuous by definition, right? So by definition, and this is knowledge, not cleverness. This is a definition that you either know or you don't. What it means to be continuous is that, so by definition, if you are continuous at some like x equals a, then the limit as x approaches a from the left of some function, and I'm just gonna, I'll use h of x here because there isn't an h in this problem to my knowledge, equals, so if h of x is continuous at x equals a, the left-sided limit approaching a is equal to the right-sided limit approaching at a, right, which is equal to the double-sided limit at a, which is equal to the actual function, h of a. Right? So that's the definition of continuity. So essentially, what we're really doing is we're going to find the left-sided limit, right? So if we wanted to do this, the limit as x approaches -3 from the left of g of x means you're plugging in this value, -3, on the left of the two functions, the function that occurs before -3. So that's going to essentially be f of -3, which is a value that we've already found. It's a 4, right? And the limit as x approaches -3 from the right of g of x is going to be this function, right? Which also happens to, for the record, g of -3 would have been this function, right? Like this is also, because the -3 is included, this also happens to be g of -3, right? Because if you had actually plugged in a -3, you'd use this. But the limit is a 4. And the limit on the right side is going to be a -3 plus a 7, which is also a 4. Since 4 equals 4, yes, it's continuous at -3. Right, so it's continuous at x equals -3. Interesting side note that they don't ask here, but they can ask, is sometimes they will ask you if something is differentiable. Sometimes they'll ask you if something is differentiable at 3. What it would mean if they asked if it's differentiable is that the derivative of both of these would also be equal at that point, at that break point of -3. So if you were asked, and you're not asked here, but if you were asked if this was differentiable, the answer would be no, because we already know from our previous work that f prime of negative, so if, and you're not asked that here, but if you were asked, is g of x differentiable, not continuous, if they asked differentiable at x equals -3, the answer would actually turn out to be no, because then what you would do is, if you were asked if it was differentiable, you'd find the derivative of each piece. The derivative of the first piece is f prime on this window. The derivative of the second piece is going to be a 1 on this window. And then you would do this same trick, but instead of doing it for g of x, you'd try it for g prime, and what you'd find is that as you approach -3 from the left, f prime of -3 gives us a 3/4, which we've already seen. But if you wanted f prime, if you wanted g prime of x from the right, you would have to plug in and just get a 1. Since 3/4 is not a 1, the answer would be no. So, and the reason would be because the left-sided limit, the limit as x approaches -3 from the left of g prime of x, would have been a 3/4, as we saw in a previous example. And the limit as x approaches -3 from the right of g prime of x would be a 1, and they're not the same number, so this is not differentiable. They don't ask that here, but that's a way they could have stepped this question up and made it slightly harder. All right, let's do D. D asks us to integrate a thing that is not this function. Now, what's interesting here is they could have made you integrate this. They didn't, because if you realize that this is just a semicircle, it's actually pretty easy to integrate this. But they don't ask that. In D, they give you a totally different function. They ask you to integrate a different thing that has an x here and a 25 minus x squared dx. So now, had they asked you to just integrate this, you'd either have to do it using your visual knowledge of this being a semicircle, or you would have had to use trig substitution, which is fairly difficult and not anybody's favorite thing ever. But they didn't do that, so they gave you a problem that's simple u sub. Now, the way I do u sub is a little different from the way other people do u sub. When I do u sub, I'm lazy and I ignore the bounds. Now, you don't have to do that. You can replace the bounds, which lots of people do. But what I do is I do it as an indefinite integral for the work purposes. So instead of changing my bounds, I say, hey, let me just go ahead and do my u sub with this indefinite integral that I at no point bother to say is equal to the actual integral. So I recognize my u is a 25 minus x squared, which makes my du a -2x dx. So du over -2x is going to be my dx. So when I plug in, the x is going to end up canceling with that x that's on the bottom. And I'm going to get that this is the integral of a -1/2 u to the 1/2 du, right? And I'm going to be able to up that power by 1, which would be 3/2, right? So I'm going to end up getting that this is a u to the 3/2, and instead of dividing by 3/2, I'm going to times by 2/3. So this 1/2 will be times 2/3. And then I'm going to put the brackets, because even though this is an indefinite integral, I actually know that I'm going back up here. So I recognize that this integrates to a -1/3 of my u, which is the 25 minus x squared, to the 3/2, evaluated from 0 to 5. Now, conventional wisdom would tell you that what you should do is change your bounds here and do U substitution and keep the bounds, but when they become U's, you change your bounds to what would end up being a 0 on the top and a 25 on the bottom. And there's nothing wrong with that. It's just not the way I usually do it. It's not cheating to do your work separately as long as at no point do you say the definite integral is equal to the indefinite integral, because they're not. So what ends up happening is I get that this is a negative 1/3. When I plug in the 5, I end up getting a 0 to the 3/2 minus a negative 1/3. And when I plug in the 0, I get a 25 to the 3/2. So this piece is a 0, which is fine, and I end up getting plus 1/3. It is important that you know how to do 25 to the 3/2. So just as a side note right here, right, 25 to the 3/2 can be evaluated in one of two ways. Either you can do 25 cubed and square root it, which is a terrible life choice, but not wrong, or you can do the much easier choice of doing the square root of 25 and then cubing it, which we can almost all do in our head and get a 125. Because I'd get the square root of 25, which is 5, and then cube it. So they both give you a 125, but one of them is something you can do as mental math, and one of them is not. So your final answer ends up being a 125/3. All right, so that's my final answer.